Welcome to my talk on Anova, a one-way analysis of variance, presented by me, Tommy Cobb. Here are a few terms that would be helpful for you to know while we go through the slide presentation. The first one is assumption. Assumptions in statistics are normality and equality of variance. An assumption must be tested for verification of truth. Homogeneity of variance. This is an assumption of the independent samples, stating that all comparison groups have the same variance, or homoscedasticity. General linear model. It's a useful framework for comparing how several variables affect different continuous variables. And p-value. The p-value is the probability of finding the observed or more extreme results when the null hypothesis of a study question is true. Within data sets, there are subsets, and within those subsets is even more data. And when you break down the data and look at it for comparison or to find differences, this might lead you to explore and find questions to answer why are those differences there, or what has happened to make those differences there. In looking at the data set of a collection of overall GPAs between college freshmen, sophomores, juniors, and seniors, you may perform an ANOVA to find the average mean between the different groupings. And let's say that you find that the freshman GPA, the average mean is 2.9. Well, that's the lowest on the scale. All of the upperclassmen GPAs, their mean is higher than the freshman. So that might make you want to look at those numbers and go, well, why is it that the freshmen performed lower than the rest of them? It would lead you to find out whether or not maybe they partied too hard their first year at college, or perhaps they weren't focused. Maybe they skipped too many of those classes. But using the ANOVA, you can find out whether or not there's a statistically significant difference in the means of the GPAs by the classification. An ANOVA tells the researcher whether the difference between the independent and dependent variables is statistically significant. An ANOVA can determine that there are differences between variables. It cannot, however, differentiate or distinguish which mean is different. In that case, you would have to perform a post hoc test. You want to use an ANOVA when you are needing to find out if there's an overall difference between more than two groups. The example that we just used about the freshmen, juniors, sophomores, and seniors overall GPAs. Another example would be if you wanted to look at GPAs based on the feeder schools that were attended. You could break down the groupings by feeder school and figure the average mean, and perhaps that might help you to understand that maybe one feeder school used programs or different approaches to help their students perform higher in their academics. In order to perform an ANOVA, your data must meet certain requirements. You must have a dependent continuous variable, an independent categorical variable, independent samples or groups, and these samples or groups must have normal distribution, and it must be a random sample from a population with a homogeneity of variances and also no outliers. You would gather your data, making certain that it meets all of the assumptions that we just talked about, the normally distributed information, the equal variances, the independence of samples, and so on. Form your research question and identify your population for study. Your hypotheses, you would have a null and an alternative hypothesis. The null hypothesis, of course, would find that the mean of GPAs in all classifications are the same. The alternative would find that at least one of the means of the GPAs is different across the classifications. Then you would perform your calculations, and based on your findings, you would either not reject or you would fail to reject the hypothesis. Things to remember about an ANOVA. It is fundamentally about mean differences. The ANOVA tells the researcher whether the difference between the independent and dependent variable is statistically significant. However, it cannot differentiate or distinguish which mean is different. And you would use an ANOVA when you want to find out if there is an overall difference between more than two groups. And finally, I would like to leave you with just a few resources for additional information.